Bright Duty. Every student matters.
Now, mathematically, if we want to express this Newton's second law, let us see how we are going to do it. Please try to relate it very seriously and sincerely. You need to practice it. Reason is this is very, very important. Let us try to relate how exactly we are going to see as to what Newton stated as per his second law. Let us relate it once again through a video presentation, an animated video which will tell you what exactly Newton's second law is telling. Now, Newton's second law, the definition we have already seen, right? Let us see the definition once again. Newton's second law states that the rate of change of momentum of a body is directly proportional or proportional to the applied unbalanced force, and it takes place in the same direction in which force is applied. So, for the calculation of mathematical expression, once again, first of all, we will consider a body of mass m at a point A such that its initial velocity is u. Let the body be acted upon by a force F for time t seconds such that at B its final velocity is v. Let small a be the representation for the acceleration of the body during this particular displacement. See, this is the body, a force is applied. Initially it was at position A. This body has an initial mass of m with initial velocity of u. After time t, it reaches point B having initial mass same, but the velocity now changes and it is represented by v. If we need to calculate the initial momentum of the body at A, we know that initial momentum is the product of mass and initial velocity, that is mu. Similarly, if we want to calculate its momentum at point B, that will be its final momentum. That final momentum is given by mass into final velocity, that is mv. Now, therefore, let us see, if we want to calculate what exactly is the change in momentum of the body. Now, the change in momentum of the body in time t will be given by final momentum minus initial momentum. Now, final momentum is mv, initial momentum is mu that we have seen earlier. So, we can say that change in momentum is equal to mv minus mu, right? Fine. Now, when we try to calculate the rate of change in momentum or the change in momentum in 1 second, we will see that the change in momentum of the body in 1 second will be m. I have taken common and now I am left with v minus u in the numerator divided by time t. But the change of the momentum of the body in 1 second is also considered to be the rate of change of momentum of the body, right? Therefore, the rate of change of momentum of the body can be expressed as small m, in bracket we have seen v minus u divided by time. Now, this is equation number 1. Also, we know that from first equation of motion we have studied that v is equal to u plus at. From here, if we try to relate the value of a, we can say that a is equal to v minus u upon t. Now, we can replace this value of a from equation number 2 in equation number 1. So, putting this value, what we will see is, let us see, putting this value of this second equation in 1, we will see that the rate of change in momentum can now be expressed as what? M into A. So, now the Newton's second law of motion that says that rate of change of momentum of the body is basically dependent or proportional to the unbalanced force that is applied. So, combining these equations, we can write force F is directly proportional to m into A, right? Now, in order to remove the sign of proportionality, what we do is if we want to convert proportionality sign into is equal to sign, we just multiply the equation with some constant, which we have done over here. We have changed the sign of proportionality in equation number 5, and we have just converted it into, or we have changed it into is equal to sign by multiplying MA with a constant K. Now what exactly is K? K is the constant of proportionality, right? Now if there be a body having a unit mass and unit acceleration such that the force possessed by it is 1 unit, then we can write the value of F to be 1. K is a constant. We'll make it as it is. Let us remain it like that only. Mass is 1 and acceleration is also 1. So based on this, we conclude that K is equal to 1. So putting the value of K to be 1 from equation number 6 in equation number 5. Now what we can do is, we can write equation number 5 as F is equal to 1 into M into A, because we have replaced K with 1. So therefore we conclude the formula to be F is equal to M into A, right? So the formula concludes to be force is equal to the product of mass and acceleration. So this is what is the conclusion of Newton's second law of motion. So going through the mathematical formulation, finally we just related and concluded that Newton's second law of motion, which was actually force is directly proportional to change in momentum divided by time. The rate of change in momentum is directly proportional to force, right? Change in momentum, we have said, that is final momentum minus initial momentum divided by time. By saying final momentum, I have replaced it with mass into final velocity minus initial momentum will be mass into initial velocity divided by time. Taking mass common, now I can write that force is directly proportional to M into V minus U upon T. This V minus U upon T, as you have seen in the animated video, that this can be replaced with acceleration because of first equation of motion. Then I have replaced this sign of proportionality by multiplying with a constant, and we have seen that the value of constant K is 1. So therefore F is equal to M into A. This is what our second law of motion given by Newton states, right? Got it? Now F is equal to M into A. That is what we stated. So from here we relate the unit of force. The unit of mass, we know that it is kilogram. The unit of acceleration is meter per second square. So the unit of force becomes kilogram into meter per second square, or it is basically Newton, right? So the standard international unit, the SI unit of force is Newton, which is represented by the symbol capital N, right? So now we related that the second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration, right? Now we have said that F is equal to M into A. From here we can also relate that A is equal to F upon M. Now A is equal to F upon M. If we try to relate this equation, we see that more force, if applied to an object, will produce more acceleration in the body. Or we can also relate that if the mass of an object is more, then in that case, providing equal amount of force, the amount of acceleration produced will be less, because they are, as per this formula, they are seemingly inversely related to each other. So if I am applying some force on a bicycle, that bicycle is going to accelerate more, but the same amount of force on a truck may not even able to move it a bit, right? So acceleration and mass, they are inversely related to each other, and the force and acceleration are directly related to each other. Got it? So this is Newton's second law of motion. Fine. Now there are certain applications of Newton's second law of motion that we will relate one by one. I hope that till here you have understood everything, and please try to do this particular derivation of Newton's second law because it is quite important. Fine.